For this lesson, we're going to be looking at dilations on a coordinate plane. So there will be new vocabulary. We're going to read it together, mark the text. So we know a dilation is a transformation that changes the size of the shape, but does not change the shape. So again, we know the size changes, but the shape stays the same. So when we look over here at our picture, notice we start with a smaller triangle. And for this triangle, it is dilated and it actually goes from a small triangle to a larger triangle. Exact same shape, but a different size. So we're going to be talking about scale factors here. And we're talking about a scale factor. If the scale factor is greater than 1, we have an enlargement. So since I said we went from small to big here, we do know that that is an example of an enlargement. If we have a scale factor that is less than 1, then we have a reduction of our pre-image. And remember, pre-image is just where are we starting? And we started with this small triangle, and that would be considered our pre-image, and this is our new size. So when we have a dilation on a coordinate plane, a figure is dilated using the scale factor, and when we represent the scale factor in our little formula, we're just going to call it B. And so when each coordinate, x and y, is multiplied by b, notice it must be the exact same number that we're multiplying x and y by. The dilation transformation, here's our rule. This is very important that we're going to remember. It's right here. We start with an x and a y. This arrow means now we're going to multiply the x and the y by a number. If that number is less than 1, we have a reduction. If the number we're multiplying here is greater than 1, we have an enlargement. All right, well, let's look at some examples that we have here and decide, is it a reduction or is it an enlargement? So give the scale factor for each dilation. So they want us to give the scale factor. Determine if the scale creates an enlargement or a reduction in size compared to the pre-image. Again, this is our pre-image. This is our new dimensions for our shape that we have. So when I'm looking at this, we can see our scale factor, I'm just going to underline it right there, is 3/10. So when we look at 3/10 and we know it is less than 1, we do know that that is a reduction. And I'm just going to put an R there. All right, so let's look at this second one. I have an X and I have a Y, and it's going to 4/3 X and 4/3 Y. Again, this is our scale factor, but 4/3 is actually greater than 1 whole. It's 1 1/3. So we know that this is going to be an enlargement, E for enlargement. Looking at the next one, we see that we have an X and a Y. So I have a 6X and a 6X. That is definitely greater than 1. This is an enlargement. Let's look at the next one. We have an X and our X and Y. Our scale factor is only 25 hundredths or 1/4. So that is definitely a reduction. And for the last one, we have our X and a Y. It's 5/2 and 5/2. Well, 5/2 is 2.5. So we do know that it is an enlargement. For each one of these, I did underline the scale factor. Notice they have to match. And then we decided, is it greater than 1 or is it less than 1 to come up with the reduction or the enlargement? So now we're going to go ahead and we're going to put that to practice. And we have 2 problems. We're going to find the new points for each dilated triangle. So dilated, we don't know. Is it a reduction or is it going to be an enlargement? And we're just going to write the new ordered pairs. So we have triangle RAT, where for X and Y, it is going to go to a 1.5X and a 1.5Y. So that means we are going to multiply each one of our points that are listed here by 1.5 or 1.5. And so when we go ahead and we do the R, our R prime, which means this is our new point, we are going to do a -4 times 1.5, and that is a -6. And then we're going to do 5 times 1.5, and that is 7.5. So there's our R. Then we're going to go to our A prime. This is our always prime is your new point. So I'm going to have my X and I'm going to have my Y. And it's a -3 times 1.5 is -4.5. And a 2 times 1.5 is a 3. So all we're doing is we're taking our scale factor they gave us and we're multiplying it by the value that is given. So let's look at T prime. For T prime, it's 0 times 1.5. Well, the X does not change, but now it's 4 times 1.5, and that is 6. So if I were to graph this, this is our original. This is the new, and since we see it is 1.5, this is definitely going to be an enlargement. It's going to be getting bigger. All right, let's look at number 2. We have triangle MAT, where our XY rule, this time it's going to be 1/2 X and 1/2 Y. Well, I wonder if you're guessing that, yep, this is a reduction, because look at our scale factor. It's less than 1. So let's see what those points would be. So we're going to have our M prime, and 2 times 1/2, we know, is 1. And 1/2 times, not 1/2, excuse me, -1 times 1/2 is going to be a -1/2. All right, now we're going to our A prime. So 4 times 1/2 is 2. And -3 times 1/2 is going to be negative. We can write it as 3/2, or we could have written it as 1.5. It doesn't matter. All right, let's go to our T prime. 2 times 1/2 is 1. And -6 times 1/2 is -3. Each one of these, again, notice the numbers, they got smaller, so this is definitely a reduction. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marcia. See you again soon.